Good morning, guys. Today is Thursday, April 9th. And as just a real quick reminder, what today is, in addition to Thursday, April 9th, it is the day before Good Friday, which is obviously the Friday before Easter Sunday. So what we're going to do is we are going to honor the school district's calendar, which has tomorrow and Monday off as holiday days. So this is going to be the last instructional video of any kind going into next week until next Tuesday, okay? So what I decided to do with that in mind is not move forward into the next section, into section 3.4, but instead just kind of wrap things up. So what you'll notice on Google Classroom after this video is there's an attached file. That file is this right here. This is a quiz or a test on sections 1 through 3 that Ms. Buchholz has used in the past. What I'm going to ask you guys to do is to do, 5 problems off of this, okay? So we're going to go through 2 of the problems on this worksheet together right now. You do not need to copy them down and turn them in, okay? They are going to be, what we're going to use is our sort of general instruction for today, okay? So we're going to go through problems number 1 on the first page. We're going to skip problem number 3 because if you'll notice, number 3 has cosine in it, and we have not yet gotten to any of the trig derivatives, okay? So we're gonna do number 1 together. We're gonna skip number 3, and then on the back page here, you'll notice there's 6, 7, and 8. We're gonna do number 8 together. Now, actually, sorry, let me flip back over real quick. If you check the directions out on 4 and 5, 2 of them that you are gonna do, the directions on 4 and 5 just say, find the intervals on which the function is increasing or decreasing and locate the relative extrema. So finding when a graph is going up or going down and finding maximums and minimums, that exclusively refers to the first derivative test. So all you're doing on 4 and 5 is finding the first derivatives, critical numbers, and then finding those points and locating them as maxes and mins, okay? Problems 6 and 7 on the back, if we read the directions, it says determine where the function is concave up or down and locate the points of inflection. So 6 and 7 are referring to exclusively the second derivative test. So on 6 and 7 for you guys today, you get to do first derivative, but then you breeze right by the first derivative's critical numbers, go to the second derivative, and find just the points of inflection. The one we're going to do together today is the one that has both. This is what you were doing yesterday, okay? It says determine the intervals where the function is increasing or decreasing and locate the relative extrema. That means do the first derivative, but pause and find the maxes and mins. Then continue on and determine intervals where it is concave up or down and locate the points of inflection. So we're going to do this one together just as kind of a general reminder of how this works when you put it all together. And this will be kind of a nice wrap up to our week going into Easter weekend when we've got an extended break. Okay, that'll allow us to start sort of fresh next week on the following section. Okay? So with that in mind, like I said, we're going to do number 8 together. We're going to do number 1 together. Number 8 is the function f of x equals 4 over 1 plus x squared. Technically speaking, anytime you have a fraction, you could move the denominator up with the numerator and turn it into a chain rule problem. The times you don't really necessarily benefit from doing that is when there's an x in the numerator, because then you turn it into a really ugly product rule, and almost it's probably better off if you just leave it as a quotient to start. Here, this is actually considerably better if we move the 1 plus x squared up to the top, give it a negative 1 exponent, because the term on top is not an expression with x, it's just a number 4. So this is when we really want to take our quotient and turn it into a product, is when our numerator does not have an x. That's going to make finding the first and second derivatives not that bad, even though it started out as a fraction and we're no longer treating it as a fraction, okay? So first derivative is obviously the chain rule. Negative 1 times 4 is negative 4. 1 plus x squared stays the same. Drop the exponent down to negative 2. And then multiply that by the derivative of the inside, which obviously would just be 2x from the x squared. Okay? So if we put these together, if I bring the 2x out front with the negative 4, it becomes negative 8x and then 1 plus x squared to the negative 2. Now, only because we're going to go on to the second derivative here, am I going to leave it like that, okay? And in reality, I'll talk a little bit more about that in just a second, but to find my critical numbers, I'm going to go ahead and write this as the fraction, negative 8x over 1 plus x squared to the second power, okay? We have to do both tests. We have to find when our what our critical numbers for the first derivative and for the second derivative are, okay? So in this case, we have to look at the bottom and the top, okay? What's weird about this is one of those problems that have been coming up pretty frequently where we look at this and we're like, wait a second, the denominator is weird because there's an x to the second power, but there's no minus sign in it. Anytime you square something, you guarantee to make it at least 0. So x squared has to be at least 0, and then you have to add 1 to that. So if the smallest the denominator can be is 0 plus 1, there's no way that the denominator can be 0. So there are no critical numbers from the bottom. The only critical number we have is from the top, and it's obviously just 0 because it would have to be negative 8 times 0. So my critical number is x equals 0. If I plug 0 back into the original problem just to find its coordinate, 0 back in up here, 1 plus 0 squared is 1. It becomes 4 over 1, which is 4. Now, the fact that that's the only critical number from the first derivative test kind of hinders me. It means I can't necessarily know if it's a maximum or minimum yet. But what I can do is sort of put that one on hold. I don't need to test numbers to the left of 0 and to the right of 0, which you may have to do on 4 and 5 to find out if it's a max or a min. I can put that on hold and find my points of inflection and probably figure it out, okay? So what we're going to do is this. We're going to jump back over to here. And now this is a case where it really doesn't matter how we do this. We can leave this as this product and find the second derivative, or we can leave it as this quotient and find the second derivative. What we've been doing is we've been doing this as a quotient rule. As soon as we get an x in our numerator, we've typically been doing the quotient rule. We could still do the product rule right here. It really wouldn't change things. So just to mix it up here, since we've been doing it as quotient rule, let's see if we can navigate it this way. Let's try and find the second derivative of this product, okay? So product rule is first negative 8x times derivative of the second. So the derivative of this would be obviously the chain rule. Bring the negative 2 down front, leave 1 plus x squared alone, drop its exponent down to negative 3, and then multiply that by the derivative of the inside, which is 2x. Okay? Some of you might watch this and be like, oh, that's actually easier leaving it as a product rule than leaving it as a quotient rule. It's all a matter of opinion. So there's no right or wrong way of doing this. So at any rate, it was first times derivative of the second plus derivative of the first, negative 8, times the second, 1 plus x squared to the negative 2. No matter whether we do product rule or quotient rule, we're going to want to factor out the common term, 1 plus x squared. So it's got 1 plus x squared to the negative 3, 1 plus x squared to the negative 2. What we want to remember is you always factor out the one with the smaller exponent. So this is where it's kind of weird here. Negative 3 is a smaller number than negative 2. So we're going to factor out 1 plus x squared to the negative 3 outside of these brackets, okay? So when you factor that out of this, look at what you're left with. Negative 8x times negative 2 times 2x. There's no distribution. It's just multiply. Negative 8x times negative 2 is 16x. 16x times 2x is 32x squared. So that whole first term cleans up incredibly nicely. This part here, you got to really remember. What do you do when you factor something out? When you factor negative 3 of these out of negative 2, when you factor some number of terms out of something, you always subtract the exponents. What's negative 2 minus negative 3? It's 1. So this actually becomes 1 plus x squared to the first power in there, which means I can distribute my -8. So I'm going to do 2 steps at once here, okay? I'm going to move these 1 plus x squareds to the bottom of a fraction, 1 plus x squared to the 3rd power, and I'm going to clean up the top. 32x squared, it's going to be plus -8, but then also -8x squared. So 32x squared minus 8x squared is going to give me 24x squared, and then it's plus a -8 or just -8. Okay? So here is my cleaned up second derivative that ends up as a quotient, even though I treated it like a product rule. Okay, we still end up with a quotient. So if we're looking for critical numbers here, our denominator is still that 1 plus x squared, so we're not going to get any critical numbers. Our critical numbers are coming out of the top. 24x squared minus 8, set it equal to 0, and then figure out what your critical x's are. Add 8, divide by 24. 8 over 24 is 1/3. So x squared equals 1/3. Square root both sides. You get this. X equals positive or negative. Square root of 1 is 1. Square root of 3 is square root of 3. Rationalize this denominator. This was throwing us off the other day just a little bit. We had those as questions. X equals, if you move the root 3 up to the top, it's positive or negative. Root 3 over 3. So unfortunately, well, 2 things here, all right? We have to find our actual points of inflection. So we have to plug in root 3 over 3 and negative root 3 over 3 back into our original function to find our 2 points of inflection, okay? So if I just kind of look back up here, jump all the way back to the beginning and fill it in wherever I can fit it. 4 over 1 plus root 3 squared. And the fact that we're squaring what we're plugging in, I'm sorry, I needed over 3. Root 3 over 3 squared. The fact that we're squaring it is what tells us it's not going to matter. It's going to be the same thing for both of these, okay? So if we think about it, what is root 3 over 3 squared? That's going to give us 4 over 1 plus root 3 squared is 3. 3 squared is 9, so it's 3 over 9, which is 1/3. This is going to get just a little bit ugly, but in the end it cleans up nicely. Because if you think about this, it's 4 over 1 plus 1/3 is 4/3. So it's 4 over 4/3. But if I change this, apologize for how squeezed in it's getting here. If I change this into 4, and I do multiplying by the reciprocal, keep the top as 4, change dividing into multiplying, and then change 4/3 into 3/4. This is 4 over 1 times 3 over 4. The 4's cancel. It's 3 over 1. So that's my y coordinate for both of these. Okay? So here are my 2 points of inflection. If anything confused us there, it was probably the arithmetic, right? Just dealing with root 3 over 3 and plugging that back in and stuff like that. It probably wasn't the differentiation, so it was the algebra, not the calculus. Okay? But here's what this also does. Both of these points of inflections are only up at 3. My extrema was up at 4, which is above that. So what does that tell me about my original first derivative? 0,4 is a max value. It's a relative max because both of the points of inflection were below it. Okay? So like I said on that one, if anything really caused us to sort of stumble on that, it was probably this arithmetic down here. Okay? So just sort of bear with me on that. Like I said, it's plugging in root 3 over 3. When you square that, you get 3 over 9, which is 1/3. So it's 4 over 4/3. Change that into multiplying by the reciprocal, and the 4's cancel, you get a 3. Okay? So, like I said earlier, your assignment today is partially just doing first derivative test, partially just doing second derivative test, and then problem number 2, which is exactly like problem number 1. So what problem number 1 gives you is a function, but it gives you a closed interval that you're going to focus on. What the directions ask for is it says locate the absolute extremes, the extrema, the absolute highest and lowest points, but only in this interval. So when you're looking for extremes, it's the first derivative test. So if you do the first derivative of this, it's obviously just 2x minus 2. If you're looking for the extremes here, you just have to figure out what x values make that 0. So add 2, divide by 2, you get x equals 1. 1 is a critical number here. 1 is a relative max or a relative min. It is in that range. So all we have to do is figure out which point in that range is the highest and lowest. 0 and whatever its y-coordinate is, 1 and whatever its y-coordinate is, or 3. You just simply take the endpoints, figure out what their coordinates are, and any relative extreme in there to figure out what are the highest and lowest points, but only in that interval, okay? So if you plug these numbers back in, 0 gives you 0 minus 0 plus 1. 1 gives you 1 minus 2 plus 1, which is 0. And then 3 gives you 9 minus 6 plus 1, which is 4. So in this interval, the lowest point, the absolute lowest point in that interval is 1, 0, because it's at 0. The absolute highest point is 3, 4, because it's at 4. So finding absolute extremes in a closed interval is really easy. You just have to do the first derivative test and then plug in any critical numbers and the endpoints and figure out which point's highest, which point's lowest. Okay, typically, like I said, typically it's not the calculus that's throwing us off. Most of the questions you guys have been asking me lately have been more so the just like complex algebra, like the working with numbers, like square roots, radicals, fractions, stuff like that. Okay, so I feel like you guys have a pretty good handle on the calculus. It's just sometimes they throw in really tricky algebra that's giving us fits. Okay, so like I said, I'm going to have this on there, but your assignment is to just to do number 2, 4, 5, 6, and 7. Okay, we did number 1 together, we did number 8 together. You do not need to fill them in from this video, and you do not need to obviously do number 3 because we have not gotten into the trig functions yet. Okay, so if you run into questions, shoot me emails. I can take a look at them individually. I'm not sure if I'll respond to them today or if I'll just wait till next Tuesday and we'll start the week out there, but shoot me any emails with any questions you do have. Other than that, have a great Thursday and I'll talk to you guys later.